press the bell icon on the YouTube app and never miss another update.
Hi students, welcome back to the online class. Today we shall continue the three-dimensional geometry. So in the first unit, you have studied about the direction ratios and the direction cosines of a straight line. And in the second unit, we have derived the equation of a line, so passing through a point and parallel to the given vector, or we can say that it is in the same direction of the line, means that they are parallel anta artha adu. Second theorem, adu first theorem statement agutte, and in the second theorem we have derived the equation of a straight line passing through the given 2 points whose coordinates are x1 y1 z1 and x2 y2 and comma z2. These are the two derivations where we have derived those two equations of the lines, both in vector form as well as in the Cartesian form. And also we have derived the formula to find the angle between the two lines. So we know that if A1 B1 C1 and A2 B2 C2 are the direction ratios of the given two lines, then the angle between them is given by the ratio. We have to take it as cos ratio here according to vector algebra. So the angle between two vectors is nothing but cos theta equal to A dot B divided by magnitude of vector A into magnitude of vector B. So according to that vector algebra here, the angle between the two lines, if their direction ratios are A1 B1 C1 and A2 B2 C2, then the formula it is given by cos theta equal to modulus of andre acute angle ige A1 A2 plus B1 B2 plus C1 C2 divided by, so root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So this is the formula to find the angle between the two lines when the direction ratios are given. Similarly, if L1 M1 N1 and L2 M2 N2 are the direction cosines of the two lines, then the angle between them is given by the formula that is equal to cos theta equal to L1 L2 plus M1 M2 plus N1 N2 divided by root of, so L1 square plus M1 square plus N1 square, whose value is nothing but 1. So, and root of L2 square plus M2 square plus N2 square. So that is whose value it is equal to 1. So therefore cos theta equal to, so in terms of direction ratios, that is cos theta, and so cos theta equal to idra value namige, so 1 anta namige identity barodrinda, so now this reduces to cos theta equal to L1 L2 plus M1 M2 plus N1 N2. So ಯಾಕೆ ಅಂದ್ರೆ L ಅಂದ್ರೆ cos theta, cos square cos alpha, cos square alpha plus cos square beta plus cos square gamma andre 1 ಆಗುತ್ತೆ. ಅದೇ ತರ ಇದು ಕೂಡ 1 ಆಗುತ್ತೆ. Therefore cos theta equal to L1 L2 plus M1 M2 plus n1 into n2. So ಇಲ್ಲಿ ನಮಗೆ so that means here in particular if theta equal to 0 degree ಹೌದಾ theta equal to 0 degree ಆದರೆ in terms of ratio theta 0 means the lines are parallel ಅಂತ ಅರ್ಥ. So therefore the condition here is a1 by a2 equal to b1 by b2 equal to c1 by c2. This is when theta equal to 0. So ಅದೇ ತರನೇ theta equal to 90 degree ಆದರೆ then the condition becomes a1 a2 plus b1 b2 plus c1 c2 equal to 0 ಆಗುತ್ತೆ. ಸೊ ಇದು ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್ ಕೊಟ್ಟಾಗ ಸೊ ನಮಗೆ ಇದು ಒಂದೇ ಇರೋದ್ರಿಂದ ಥೀಟಾ 90 ಡಿಗ್ರಿ ಆದರೆ ಕಾಸ್ 90 ಡಿಗ್ರಿ 0 ಆಗುತ್ತೆ. therefore the condition is L1 L2 plus M1 M2 plus N1 N2 equal to 0. ಸೊ ಅದು ಒಂದೇ ಬರುತ್ತೆ ನಮಗೆ ಪ್ಯಾರಲಲ್ಲಿಗೆ. ಸೊ ನೆಕ್ಸ್ಟ್ that is for perpendicular condition. So maximum we use this condition while solving the competitive part problems. So now we have derived this angle between the two lines as well as the condition for the lines to be parallel and for the lines to be perpendicular in terms of the direction ratios as well as the direction cosines. So now we have to solve the problems based on this angle as well as that is exercise problems. So today we shall solve those problems. So we have to find the angle between the vector. Houda? Find the angle between, first example here, find the angle between the pair of lines, vector r equal to 3i plus 2j minus 4k, so plus lambda times, so that is I plus 2j plus 2k. So I plus 2j plus 2k. And second line is vector r equal to 5i minus 2j plus mu into, so that is 3i plus 2j, so plus 6k. And also after deriving the formula, so we also know that if the given two lines, so theorem 1 ಪ್ರಕಾರ ಎರಡು ಲೈನ್ಗಳನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೀವಿ ನಾವಿಲ್ಲಿ. ವೆಕ್ಟರ್ a1 ಪ್ಲಸ್ ಲ್ಯಾಂಬ್ಡಾ ಟೈಮ್ಸ್ ವೆಕ್ಟರ್ b1, ವೆಕ್ಟರ್ r ಈಕ್ವಲ್ ಟು ವೆಕ್ಟರ್ a2 ಪ್ಲಸ್ mu into vector b2. ನೋಡಿ the two lines here. So now this is the first line L1 and this is the second line L2. The angle between the two lines, suppose this is L1 line and this is L2 line. We know that here the line L1, idu L1 line alli, this line it is parallel to vector b1, andre parallel to vector b1. This is vector b1. L2 line ige this is parallel to vector L2. L2 ಗೆ parallel ಇರುತ್ತೆ, ಕೆಳಗಾದ್ರೂ ಬರ್ಕೊಳ್ಳಿ ಮೇಲಾದ್ರೂ ತಗೊಳ್ಳಿ. So then you take here and this is vector b2. ಹೌದಾ? ಎರಡು ಲೈನಿಗೆ ಕೊಟ್ಟಿರುವಂತ the angle between the two lines, it is same as the angle between the two vectors. ನೋಡಿ the angle between the two lines, it is same as the angle between the two vectors. So therefore, when the lines are in the form of the theorem 1, that is vector r equal to vector a1 plus lambda into vector b1, so then, and another line is vector r equal to vector a2 plus mu into b2, then the angle between them is given by cos theta equal to, ನೋಡಿ ಈ ವೆಕ್ಟರ್ಸ್ಗಳಲ್ಲಿ ನಾವು ಫಾರ್ಮುಲಾನ ಬರ್ಕೋಬೇಕು. ಅದಕ್ಕೆ ವೆಕ್ಟರ್ ಆಲ್ಜಿಬ್ರಾ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ ಅಂತ ಹೇಳೋದು. ಮಾಡ್ಯುಲಸ್ ಆಫ್ b1 vector dot b2 vector divided by magnitude of vector b1 into magnitude of vector b2. So here if theta is the, so solution, if theta is the angle between the given lines 1 and 2, then cos theta equal to vector b1 dot vector b2 divided by magnitude of vector b1 into magnitude of vector b2. So now in the given lines, so we have to know what is vector b1, idu vector b1 agutte, idu vector b2 agutte. So kottiro lines alli just you note that figure, then will come to know that. So where you write vector b1 andre ಮೊದಲನೇ ಲೈನ್ ಅಲ್ಲಿ I cap plus 2 into j cap plus 2 into k cap, and vector b2 it is equal to ಎರಡನೇ ಲೈನ್ ಅಲ್ಲಿ 3 times I cap plus 2 times j cap plus 6 times k cap. We have to write vector b1 and vector b2. I hope you have understood this concept here. That is how we have applied the vector algebra part. So now here we know to take the dot product of two vectors. The dot product of two vectors. ಎರಡು ವೆಕ್ಟರ್ಗಳ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ನಾವು ತಗೋಬೇಕು ಅಂತಂದ್ರೆ, ಸೊ ಅವುಗಳ ಐ ಕಾಂಪೋನೆಂಟ್ಸ್ ಗಳನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು, ಜೆ ಕಾಂಪೋನೆಂಟ್ಸ್ ಗಳನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು, ಅದೇ ತರನೇ ಕೆ ಕಾಂಪೋನೆಂಟ್ಸ್ ಗಳನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಕೊಂಡು ಅವುಗಳನ್ನ ಆಡ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ನಾವು ಈಗ ಈ ಫಾರ್ಮುಲಾಗೆ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ, ಸೊ ದೇರ್ ಫೋರ್ equation 3 becomes ಇದನ್ನ ಎಕ್ಸಾಂಪಲ್ ಕೇಳಿದಾರೆ ನೋಡಿ. ಸೊ ದಟ್ ಈಸ್ 3 marks ಪ್ರಾಬ್ಲಮ್ ಕೇಳ್ತಾರೆ, ಇದನ್ನ ಎಕ್ಸಾಂಪಲ್ ಸೇಮ್ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದ್ದಾರೆ. ಸೊ equation 3 becomes cos theta equal to modulus of, ಇದರಲ್ಲಿ I cap ಕಾಂಪೋನೆಂಟ್ 1 ಇದೆ, ಇದರಲ್ಲಿ 3 ಇದೆ, ಸೊ ಪ್ಲಸ್ ಅದರಲ್ಲಿ ಪ್ಲಸ್ 2 ಇದೆ, ಇದರಲ್ಲಿ 2 ಇದೆ, ಸೊ ಪ್ಲಸ್ ಅದರಲ್ಲಿ ಪ್ಲಸ್ 2, ಸೊ ಇದರಲ್ಲಿ 6 ಇದೆ. ಸೊ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ ಆಫ್ a1 square magnitude of b1 vector. So here a1 square plus b1 square plus c1 square 1 plus 4 into root of idak banni 3 square is 9 plus 2 square is 4 plus 36. So iga ಮೇಲ್ಗಡೆ ಅದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ಆಡ್ ಮಾಡಿ. So 3 plus 4, what is 3 plus 4? 7 plus 12. 7 plus 12 andre 19 divided by root 9 andre 3 into root 49 andre 7. So therefore cos theta equal to 19 by 21. So therefore theta equal to cos inverse of 19 by 21. So that is the angle between the given two lines So which are where the lines are in the vector form. So according to theorem 1. Theorem 1 ಪ್ರಕಾರ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರುವಂತ ಲೈನ್ಸ್ ಗಳಿವು. So that is the angle between the given two lines. So now we shall take another next example. That is, we have to find the angle between, that is next example. Find the angle between the pair of lines next take the question. Find the angle between the pair of lines. Here the lines are given in the Cartesian form. So Cartesian form alli avaru kottidare. We have to check. So the Cartesian form, general form ಏನide ಅಲ್ಲ Cartesian, x minus x1 divided by a ಅದೇ ಫಾರ್ಮ್ ಅಲ್ಲೇ ಇರಬೇಕು ಅವು, equal to y minus y1 divided by b equal to z minus z1 divided by c. ಆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮಿಗೆ ಬರ್ದಾದ್ಮೇಲೆನೆ ನಾವು ಎ ಬಿ ಸಿ ಗಳನ್ನ ತಗೋಬೇಕಾಗುತ್ತೆ, ಇಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ ಎ ಬಿ ಸಿ ವ್ಯಾಲ್ಯೂಸ್ಗಳು ತಪ್ಪಾಗುತ್ತೆ. So pair of lines, that is x plus 3 divided by 3 equal to y minus 1 divided by 5 equal to z plus 3 divided by 4, and x plus 1 divided by 1 equal to y minus 4 divided by 1 equal to z minus 5 divided by 2. So solution. ಸೊ ಯಾಕೆಂದ್ರೆ ನಾವು ಯಾವಾಗ್ಲೂ ಅದರ ಜನರಲ್ ಫಾರ್ಮಿಗೆ ಬರೆದ್ರೇನೆ ಎಲ್ಲ ನಾವು ಯಾವಾಗ್ಲೂ ಪರ್ಫೆಕ್ಟ್ ಇದೀವಿ ಅಂತ. ಅವ್ರು ಏನ್ ಕ್ವಶನ್ ಕೇಳಿದ್ರು ಅವಾಗ ನಮಗೆ ತಪ್ಪಾಗೋದಿಲ್ಲ. ಈಗ ಇದನ್ನು ವೆಕ್ಟರ್ ಫಾರ್ಮಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಪಾಯಿಂಟ್ ಎ ಇದೆ ಎಲ್ಲ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಪಾಯಿಂಟ್, ಅದರ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಬೇಕಾಗುತ್ತೆ. ಸೊ ನಾವು ದ ಗಿವನ್ ಲೈನ್ಸ್ ಆರ್ you take L1 first line, x minus of minus 3 nodi divided by 3, x minus x1 equal to y minus 1 divided by 5, z minus of minus 3, so divided by 4. Next, the second line, I think it is also minus of minus 1 divided by 1 equal to y minus 4 divided by 1 equal to z minus 5 divided by 2. Note. So now here x minus x1 divided by a1 ಇದು ಮೊದಲನೇ ಲೈನಿನ ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್, ಅಂದ್ರೆ ಪ್ಯಾರಲಲ್ ವೆಕ್ಟರ್ ಏನಿದೆ ಅಲ್ಲ, ಸೊ ಅವುಗಳ ಕಾಂಪೋನೆಂಟ್ಸ್ ಇವು ಕೆಳಗಡೆ ಬರೋದು ಎ ಬಿ ಸಿ. they are nothing but the components of vector b. So therefore here so a1 equal to 3, b1 equal to 5 and c1 equal to 4. Next ಎರಡನೇ ಲೈನ್ ಅಲ್ಲಿ a2 equal to 1, b2 equal to 1, c2 equal to 2. So now if theta is the angle between, ಹೌದಾ, if theta is the angle between the lines, so 1 and 2 ಅಥವಾ L1 and L2 ಎಲ್ಲ ಒಂದೇ, L1 and L2, then cos theta equal to, ನೋಡಿ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್ ಆಫ್ ವೆಕ್ಟರ್ b1 and b2 ಗೊತ್ತಾಗಿದೆ, ಹಾಗಾಗಿ ಫಾರ್ಮುಲಾನ ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್ ದಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ. ದಟ್ ಈಸ್ a1 a2 ಪ್ಲಸ್ b1 b2 ಪ್ಲಸ್ c1 c2, so divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So now cos theta becomes a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Now you substitute the values here. So ಇಲ್ಲೇ ನೋಡ್ಕೊಂಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ತಗೊಳ್ಳಿ. So that is equal to ತುಂಬಾ ಸ್ಟೆಪ್ಸ್ ಬರೆದ್ರೆ ಟೈಮ್ ಭಾಳ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. 3 into 1 ಅಂದರೆ 3 plus 5 into 1 ಅಂದರೆ 5 plus 4 2s are 8 divided by root of a1 square 9 plus 5 square 25 plus 4 square 16 into root of a2 square is 1 plus 1 plus 4. That is cos theta equal to ನೋಡಿ ಏನು ಬರುತ್ತೆ ಅವಾಗ ಆನ್ಸರ್ we get cos theta equal to that is 8 plus 8 ಅಂದರೆ 16. So divided by so root ಎಷ್ಟಾಗತ್ತಪ್ಪ ಅದು 25 root 50 into root 6 ಹೌದಾ that is equal to 16 divided by 25 into 2 ಅಂತ ಬರೆದ್ರೆ then it becomes 5 root 2 ಇದನ್ನ root 3 into root 2 ಅಂತ ಬರ್ಕೋಬಹುದು. Now this becomes 16 divided by 5 into root 3 root 2 into root 2 ಅಂದರೆ 2 ಆಗುತ್ತೆ 2 ones are 2 8 that is 8 divided by 5 root 3. So cos theta equal to 8 divided by cos theta equal to 8 by 5 root 3. So therefore theta equal to cos inverse of 8 divided by 5 root 3. So now this is the angle between the two given pair of lines. So ಒಂದರಲ್ಲಿ ನಮಗೆ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇನ್ನೊಂದರಲ್ಲಿ ಕಾರ್ಟೀಷಿಯನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. So now we shall or this can also be written as ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ ರೂಟ್ 3 ಮಾಡಿದ್ರೆ ಅವಾಗ 8 ರೂಟ್ 3 ಡಿವೈಡೆಡ್ ಬೈ 15 ಆಗುತ್ತೆ. ದಿಸ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಬಿ ರಿಟರ್ನ್ ಆಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ 8 ರೂಟ್ 3 ಡಿವೈಡೆಡ್ ಬೈ 15. We have to multiply and divide by root 3 ಮಾಡ್ಕೊಂಡ್ರೆ ಅವಾಗ ಆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ. So that is the angle between the given two pair of lines. So now we shall solve the problems so of exercise 11.2. So better to keep the textbook with you and see the question. ಏಕೆಂದರೆ ಕ್ವಶನ್ ಇಲ್ಲಿ ಉದ್ದ ಇರುತ್ತೆ. ಸೊ ಇಫ್ ಯು write down the question by seeing the textbook, so we can save little bit time here. ಹಾಗಾಗಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕನ್ನ ಸೊ ನಿಮ್ಮ ಜೊತೆಲಿ ಇಟ್ಕೊಳ್ಳಿ, ಏಕೆಂದರೆ ಇಷ್ಟುದ್ದ ಎಲ್ಲ ಬರ್ಸಕ್ಕೆ. We have to find the first question is the direction cosines of the three lines are given here. ನೋಡಿ ಮೂರು ಲೈನ್ಗಳ ಡೈರೆಕ್ಷನ್ ಕೊಸೈನ್ಸ್ಗಳನ್ನು ಅವರು ಕೊಟ್ಟಿದ್ದಾರೆ. We have to prove that they are mutually perpendicular to each other. We have to show that the direction cosines of three lines. ಹೌದಾ? ಸೊ ಮೊದಲನೇ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ the direction cosines of the three lines are given and we have to show that those three lines are mutually perpendicular to each other. So now you take the three lines as L1, L2 and L3. So exercise 11.2 exercise. So 11.2, so ಈ ಎಕ್ಸೈಸ್ ಅಲ್ಲಿ ಮೊದಲನೇ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಸೊ ಲೆಟ್ L1, L2 and L3 be the given three lines. The direction cosines of the lines are given. Of the lines are given. We have to prove that they are perpendicular to each other. So adralli the direction cosines of the first line L1 are given by, that is 12 by 13, 12 by 13, comma, minus 3 by 13, comma, minus 4 by 13. L1, L2, L3. Next, the direction cosines of L2 are given as, so 4 by 13, 12 by 13 and another is 3 by 13. The direction cosines of, not ratios here, sorry, the direction cosines of the third line L3 are, the direction cosines of L3 are 3 by 13, comma, minus 4 by 13 and 12 by 13. We have to prove that the three lines are mutually perpendicular to each other. To show that L1 and L2 are perpendicular when the direction cosines are given, L1, M1, N1, L2, M2, N2. So when the direction cosines are given, so perpendicular under theta 90 degree, and hence we have to show that L1, L2 plus M1, M2 plus N1, N2 equal to 0 ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ಬೇಕು. ಸೊ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ನೋಡಿ, ಮೊದಲನೇದರಲ್ಲಿ the lines L1 and L2 are perpendicular if L1, L2 plus M1, M2 plus N1, N2 equal to 0. That is, L1 andre idu 12 by 13 into L2 is 4 by 13 plus minus 3 by 13, so plus 12 by 13, next plus minus 4 by 13, so into 3 by 13. So consider you take the LHS equal to, now so denominator alli elladrallu nanige 13 square ide, LCM is 13 square, that is 12 4s are 48 minus 12 3s are 36 minus 12. So that is equal to 48 minus 48 by 169, that is equal to 0, equal to RHS. So it implies that, so L1 it is perpendicular to L2. So L1 is perpendicular to L2. Now we have to prove that L2 is perpendicular to L3. L2 is perpendicular to L3. So now, so secondly, the lines, so you aage idkollona, so subdivision 2 alli, so the lines L2 and L3 are perpendicular if, so L1 L2 plus M1 M2 plus n1, n2 equal to 0. Now you take LHS of this part. ಈಗ ಸೆಕೆಂಡ್ ಮತ್ತೆ ಥರ್ಡ್ ಲೈನ್ ಅಂದರೆ ಇವುಗಳನ್ನು ತಗೊಳ್ಳಿ. L1 into L2, 4 3s are 12. ಸೊ 12 by ಎರಡನ್ನೂ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 13 ಸ್ಕ್ವೇರ್. Plus into minus is minus. 12 4s are 48 by 13 square. Next, ಇವೆರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 12 3s are 36 by 13 square. Now 13 square ಅಂದರೆ 169. So 12 minus 48 plus 36. So that is equal to 48 minus 48 divided by 169. That is 0. By 169 andre 0. So this implies that second line it is perpendicular to the third line. Similarly, we have to show that the lines L1 and L3 are perpendicular. So we have to show that the lines L2, L3 and L1 are perpendicular. So subdivision 3 here, subdivision 3, the lines L3 and L1 are perpendicular if, so L1 L2 plus M1 M2 plus N1 N2 equal to 0. ಅಂದರೆ ಈಗ ಥರ್ಡ್ ಲೈನ್ ಕೊಸೈನ್ಸ್ ಫಸ್ಟ್ ಲೈನ್ ಕೊಸೈನ್ಸ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 12 into 3, 12 3s are, now you take LHS, 12 3s are 36 by 169, minus into minus plus, 12 by 169, plus into minus is minus, 12 4s are 48 by 169, that is equal to 169 LCM, 36 plus 12 minus 48. Denominator same ide, numerator as it is simplify ಮಾಡ್ಕೋಬೇಕು. So now we get 48 minus 48 by 169, that is equal to 0. So therefore the third line it is perpendicular to the first line. Since L1 is perpendicular to L2 and L2 is perpendicular to L3 and L3 is perpendicular to L1, we conclude that the three lines are mutually perpendicular to each other. So ಒಟ್ಟಿಗೆ ಸೇರಿಸಿ ಹೇಳೋದಾದ್ರೆ we say that the given three lines are perpendicular to each other. So that is the proof of the theorem. ಸೊ ನಮಗೆ ಏನು ಮಾಡ್ತಾರಂದ್ರೆ 2 marks ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಎರಡು ಲೈನ್ಗಳ ಕೊಸೈನ್ಸ್ ಅನ್ನ ಕೊಟ್ಟು ಶೋ ದಟ್ ದ ಲೈನ್ಸ್ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಂತ ಕೇಳ್ತಾರೆ. Now you take down the second problem in the textbook. So now show that the line passing through the points, we have to show that second problem, we have to show that the line passing through the points is perpendicular to the line passing through the given 2 points. Show that the line through the points, the 1 minus 1 2, and the second point is 3 4 minus 2 is perpendicular to the line through the points 0, 3, 2, and second point 3, 5, 6. So here little bit the first unit part al now ಮಾಡಿದೀವಲ್ಲ, we have to show that the line passing through the points, you take the first 2 points as A and B, A and B. The line passing through the points A and B is perpendicular to the line passing through the points C and D. ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಇವನ್ನ. ಅಂದರೆ ಲೈನ್ ಎ ಬಿ ಮತ್ತು ಲೈನ್ ಸಿ ಡಿ. ಇನ್ ದ ಫಸ್ಟ್ ಯೂನಿಟ್ we have studied about the direction ratios of the line joining the given 2 points. ಸೊ 2 ಪಾಯಿಂಟ್ಗಳು ಕೊಟ್ಟಿರ್ತಾರೆ, ಅವೆರಡು ಪಾಯಿಂಟನ್ನು ಜಾಯಿನ್ ಮಾಡಿದ್ರೆ, ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರೆ ಒಂದು ಲೈನ್ ಸಿಗುತ್ತೆ. The line, the direction ratios of the line joining the given 2 points ಅಥವಾ the line passing through the given 2 points. ಎರಡು ಮೀನಿಂಗ್ ಒಂದೇನೆ ಬರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ನಾವೇನ್ ಮಾಡಬೇಕು, ಎ ಬಿ ಲೈನ್ ಅಂದಿದೆ ಅಲ್ಲ, ಅದನ್ನ take the first point as A, 1, -1, 2, and the second point as B, to take it as 3, 4, -2. So now this is x1, y1, z1. ನೋಡಿ ಮೊದಲನೇ ಯೂನಿಟ್ ಇದೆ ಇಲ್ಲಿ z2. Now you find the direction ratios of the line AB. The direction ratios of the line AB are, they are given by the formula x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. Now x2 andre 3 minus 1, next y2 is 4 minus into minus plus 1, comma, z2 is -2, -2. So now the direction ratios of the line AB are 2, 5, -4. ಇದು A1, B1, C1. A1, B1, C1 ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. So these are the direction ratios of the line AB, which are nothing but A1, B1, C1. Similarly, we have to find the direction ratios of the line CD. ಈಗ next ಪಾರ್ಟಿಗೆ ನಾವು take C equal to 0, 3, 2 and D equal to 3, 5, 6. This is x1, y1, z1, x2, y2, z2. The direction ratios of the line CD are, ಸೊ ಈಗ ಮತ್ತೊಂದ್ಸಲ ಫಾರ್ಮುಲಾ ಬರೆಯೋದು ಬೇಡ. ಸೊ ವ್ಯಾಲ್ಯೂ ಫಾರ್ಮುಲಾ ಹೇಳ್ತಾ ಎಂಟ್ರಿ ಮಾಡ್ತಾ ಹೋಗಿ. x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. That is 3, comma, 5 minus 3, 2, 4. These are nothing but A2, B2, C2. To prove that the two lines are perpendicular when their direction ratios are given, we know the formula. ನಮಗೆ ಡೈರೆಕ್ಷನ್ ಕೊಸೈನ್ಸ್ ಕೊಟ್ಟಾಗ ಫಾರ್ಮುಲಾ ಬರ್ಕೊಳ್ಳೋದು ಗೊತ್ತಿರಬೇಕು, ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್ ಗೊತ್ತಿದ್ದಾಗ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಬೇಕು. ಸೊ the two lines with the direction ratios A1, B1, C1 and A2, B2, C2 respectively are A1, A2 plus B1, B2 plus C1, C2 equal to 0. ಈಗ ನಾವು ಎ ಬಿ ಲೈನ್ ಮತ್ತೆ ಸಿ ಡಿ ಲೈನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಂತ ಪ್ರೂವ್ ಆಗಬೇಕಾದ್ರೆ ವಿ ಹ್ಯಾವ್ ಟು ಶೋ ದಟ್ A1, A2 plus B1, B2 plus C1, C2 equal to 0 ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ಬೇಕು. ಸೊ ಟು ಶೋ ದಟ್ the lines AB and CD are perpendicular, comma, we have to prove that A1, A2 plus B1, B2 plus C1, C2 equal to 0. Now you take the LHS part. ಮೊದಲನೇ ಲೈನಲ್ಲಿ A1 is 2, ಸೆಕೆಂಡ್ ಲೈನಲ್ಲಿ A2 is 3 plus B1 is 5, B2 is 2 plus C1 is minus 4, ಅದರಲ್ಲಿ C2 is plus 4, that is equal to 6 plus 10 minus 16, that is 16 minus 16 equal to 0. ನಮಗೆ RHS ಬಂತು. So implies that the lines are perpendicular to each other. So implies the lines are perpendicular. The lines are perpendicular. So that is the proof of the second problem. Now you take the third example. So we have to show that the line through the points. So next, third example, show that the line through the points through the points 4, 7, 8, 4, 7, 8, 2, 3, 4 is parallel to the line is parallel to the line through the points minus 1, minus 2, 1 and 1, 2, 5. 1, 2, 5. So perpendicular andre the direction ratios of two lines. Illu ashtane nodi, we have to find the direction ratios of the two lines. First ಎರಡು ಪಾಯಿಂಟ್ ಗಳನ್ನ ಜಾಯಿನ್ ಮಾಡಿದಾಗ ಒಂದು ಲೈನ್, ಸೆಕೆಂಡ್ ಎರಡು ಪಾಯಿಂಟ್ ಗಳನ್ನ ಜಾಯಿನ್ ಮಾಡಿದ್ರೆ ಇನ್ನೊಂದು ಲೈನ್. ಆ ಎರಡು ಲೈನ್ಗಳ ಡೈರೆಕ್ಷನ್ ರೇಷಿಯೋಸ್ ಅನ್ನ ಕಂಡುಹಿಡ್ಕೋಬೇಕು. ಸೊ and we have to show that parallel ಅಂದಾಗ we have to show that so their the ratios are proportional ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ಬೇಕು. So now solution. Take A equal to 4, 7, 8, B equal to 2, 3, 4, C equal to minus 1, minus 2, 1 and D equal to 1, 2, 5. The direction first AB line ಅನ್ನು ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. x1 y1 z1 x2 y2 z2. The direction ratios of the line AB are given by x2 minus x1 2 minus 4 comma y2 minus y1 z2 minus z1, that is minus 2 minus 4 minus 4. Next ಅದೇ ತರನೇ the direction ratios of the line CD are C ಮತ್ತೆ D ಗೆ ತಗೊಳ್ಳಿ. C coordinates x1 y1 z1 x2 y2 z2. x2 minus x1 1 minus into minus plus 1 comma y2 minus y1 negative ಇದೆ, it becomes positive comma z2 minus z1, that is 2 comma 4 comma 4. So here a1 is ನೋಡಿ a1 by a2 it is equal to b1, ಇದು a1 b1 c1, ಇದು a2 b2 c2. Now the lines AB and CD are parallel if A1 by A2 equal to B1 by B2 equal to C1 by C2. Now A1 is minus 2 divided by plus 2 equal to minus 4 divided by 4 equal to minus 4 divided by 4. That means here we get minus 1 equal to minus 1 equal to minus 1. That is, so means that the given lines are parallel. So the direction ratios are proportional anta artha allige. So therefore the given two lines are parallel anta conclusion ಬರೆಯಬೇಕು. So that is the problem. Next we have to find next example. Now you take down the fourth example, that is find the equation of the line passing through the points. Find the equation of the line. I think you can solve by yourself. Find the equation of the line passing through ಅಥವಾ through the point, ಎಲ್ಲ ಒಂದೇ, passing through 1, 2, 3 and parallel to the vector and parallel to the vector 3i plus 2j minus 2k. ಈಕ್ವೇಶನ್ ಆಫ್ ದ ಲೈನ್ ನಾವು ಬರೀಬೇಕಾದ್ರೆ ಯಾವಾಗಲೂ ಅವ್ರು ಕೊಟ್ಟಿರೋದು ಡೇಟಾ ಅಕಾರ್ಡಿಂಗ್ ಟು ಥೇರಮ್ 1 ಇದೆನೋ ಅಥವಾ ಥೇರಮ್ 2 ಇದೆನೋ ಅಂತ ಗೊತ್ತು ಮಾಡ್ಕೋಬೇಕು. I think this problem, it is according to the theorem 1. We have to find the equation of the line L where it passes through the point and parallel to the vector, that is 3i plus 2j minus 2k. ಹೌದಾ? ಇದನ್ನ ನಾನು ವೆಕ್ಟರ್ ಬಿ ಅಂತ ತಗೋಬೇಕು. ಇದರ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಅನ್ನ ನಾನು ಓ ಎ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಅನ್ನ ಸ್ಮಾಲ್ ಎ ವೆಕ್ಟರ್ ಎ ಅಂತ ತಗೋಬೇಕು. ಐ ಜೆ ಕೆ ಅಲ್ಲಿ ಬರೀಬೇಕು. We have to find the equation of the line passing through the point 1, 2, 3 and parallel to the vector. ಹೌದಾ? Now this is according to the theorem 1. We have to write the equation both in vector form as well as in the Cartesian form. Take the point as 1, 2, 3 and therefore vector A, it is nothing but the position vector of the point A, I plus 2j plus 3k. Next, take vector B, it is equal to 3i plus 2j minus 2k. The vector form of the vector form of the line is vector R equal to vector A plus lambda times vector B. So this is according to theorem 1. So now that is vector R equal to I plus 2j plus 3k, ಹೌದಾ? plus lambda times vector B ಅಂದ್ರೆ ಇದು 3i plus 2j minus 2k. This is the vector form of the line. So now we have to write the Cartesian form of the line. The Cartesian form. The Cartesian form is x minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 divided by c. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಏನು ಕೊಟ್ಟಿದಾರಲ್ಲ ಇದೇ x1 y1 z1, ವೆಕ್ಟರ್ b ಏನು ಕೊಟ್ಟಿದಾರಲ್ಲ ಅವುಗಳ ಕಾಂಪೋನೆಂಟ್ಸ್ಗಳನ್ನೇ ನಾವು ತಗೊಳ್ಳೋದು. a ವ್ಯಾಲ್ಯೂ ಪ್ಲಸ್ 3, b ವ್ಯಾಲ್ಯೂ ಪ್ಲಸ್ 2, c ವ್ಯಾಲ್ಯೂ ಮೈನಸ್ 2 ತಗೋಬೇಕಿಲ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ x minus 1 divided by 3 equal to y minus y1 2 divided by b value is plus 2 equal to z minus 3, z1 andre 3 divided by c value minus 2. So now this is the equation of the line. And this can also be written as, ಇದನ್ನ ನೋಡಿ ಇದನ್ನ ಈ ತರನೂ ಬರೀಬಹುದು, ಯಾಕೆಂದ್ರೆ ನಮಗೆ ಅವರು ಕೊಡಬೇಕಾದ್ರೆ ಲೈನ್ ಅನ್ನು ಆ ಫಾರ್ಮ್ ಅಲ್ಲೂ ಕೊಟ್ಟಿರ್ತಾರೆ. ಮೈನಸ್ ಇಂದ ಮೇಲ್ಗಡೆ ಮೈನಸ್ ಕಾಮನ್ ತೆಗೆದು ಮೈನಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತೆ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ 3 ಮೈನಸ್ ಝೆಡ್ ಡಿವೈಡೆಡ್ ಬೈ 2. ಇದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅವ್ರು ಈ ತರ ಕೊಟ್ರೆ ನಾವು ಈ ತರನ ಅದನ್ನ ಬರ್ಕೋಬೇಕಾಗತ್ತೆ. ಝೆಡ್ ಯಾವಾಗ್ಲೂ ಮುಂಚೆ ಇರಬೇಕು, 1 ಝೆಡ್ ಇರಬೇಕು, ಪ್ಲಸ್ ಇರಬೇಕು, ಅದು ಅವಾಗ ನಾವು ಆ ಫಾರ್ಮಿಗೆ ಬರೀಬಹುದು. ಸೊ ನಾವು ದಿಸ್ ಈಸ್ ದ required equation of the line both in vector form as well as in the Cartesian form. So now we shall solve the fifth problem. So we have to find we have to find the equation of the line both in vector and Cartesian form passing through the point with position vector. ನೋಡಿ position vector ಅಂತ ಅವರೇ ಹೇಳಿದ್ದಾರೆ 2i minus j plus 4k. Fifth example, we have to find the equation of the line passing through the point whose position vector whose position vector is 2i minus j plus 4k. 2i minus j plus 4k cap and in the direction ನೋಡಿ ಇಲ್ಲಿ ವರ್ಡ್ ಸ್ವಲ್ಪ ಬೇರೆ ಕೊಟ್ಟಿದ್ದಾರೆ, ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಂಗಿಲ್ಲ. and in the same direction, ಲೈನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆನೋ ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಈ ವೆಕ್ಟರ್ ಇದೆ ಅಂದ್ರೆ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಸೇಮ್ ಲೈನ್ ಮೇಲೆ ಅಂದ್ರೆ ಪ್ಯಾರಲಲ್ ಅಂತ ಅರ್ಥ. ಅದು ಡೈರೆಕ್ಷನ್ i plus 2j minus k cap. So this is also according to theorem 1 again, passing through a point. ಒಂದು ಪಾಯಿಂಟ್ ಮೂಲಕ ಪಾಸ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವಾಗಲೂ ಅದು ಥೇರಮ್ 1. ಯಾಕಂದ್ರೆ ಥೇರಮ್ 2 ಅಲ್ಲಿ ದ ಲೈನ್ ಇಟ್ ಪಾಸಸ್ ಥ್ರೂ ದ 2 ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರ ಅವರು. ಸೊ ಹಾಗಾಗಿ ಅದು ಥೇರಮ್ 2 ಆಗುತ್ತೆ. ನಾವು ಅವ್ರು ಕೊಟ್ಟಿರೋ ಡೇಟಾ ಏನಿದೆಲ್ಲ ಅದನ್ನ ಸಿಂಬಾಲಿಕಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿ passing through the point A whose position vector is andre vector A, that is 2i minus j plus 4k take. So implies the point it becomes 2 minus 1 4 x1 y1 z1. And in the same direction andre idu vector B, I cap plus 2 j cap minus k cap. So idralli A into I cap according to theorem, A into I cap, A value 1, B value 2, C value minus 1. So idralli implies A equal to 1, B equal to 2 and C equal to minus 1. So ಈಗ ಮೊದಲನೇದು the vector form of the line is vector r equal to vector A plus lambda times vector B, that is vector r equal to 2i minus j plus 4k. So plus lambda into vector B, I plus 2j minus k. So this is the vector form of the given line. Now ಎರಡನೇದು the Cartesian form of the line is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. The Cartesian form of the line is given by the formula x minus x1 by a equal to y minus y1 divided by b equal to z minus z1 divided by c. that is x minus 2 divided by a value 1, y minus y1 is plus 1 divided by b value 2 equal to z minus z1 andre 4 divided by minus 1. Or this can also be written as x minus 2 divided by 1 equal to y plus 1 divided by 2 equal to 4 minus z divided by 1. ಸೊ ನಾವು ನೋಡಿ ಈ ತರ ಈಕ್ವೇಶನ್ ಅವ್ರು ಕೊಟ್ಟಾಗ ಎ ಬಿ ಸಿ ಬರ್ಕೋಬೇಕು ಅಂದ್ರೆ ನಾವು ಅವಾಗ ಈ ಜನರಲ್ ಫಾರ್ಮಿಗೆ ಬರ್ದ್ರೆ ಸಿ ತಗೋಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ದ ಮೆಥಡ್. ಸೊ ದಟ್ ಈಸ್ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ದ ಫಿಫ್ತ್ ಪ್ರಾಬ್ಲಮ್. ಐ ಥಿಂಕ್ 2 or 3 ಎಕ್ಸಾಂಪಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್. ಸೊ ಇನ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಥಿಯರಮ್ 2 ಪ್ರಕಾರ ಇರುವಂತದ್ದನ್ನ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ ನಿಮಗೆ ಬರುತ್ತದು. So you can solve according to that second theorem, passing through 2 points. So thank you students. So we shall continue in the next session or the next video class. Thank you.